Hello everyone, welcome back to the RLR method. I'm sure you would have mastered the formula that we discussed in our previous video, which was the HCF multiplied by LCM of two numbers is equal to the product of two numbers. It was simple, clean and smooth. But what if in your exam you get a question like find the smallest number that leaves a remainder? So let's find out how to crack the problems that leave a remainder, and in this video we are going to see that step by step. So first of all, just to understand that leaving a remainder, how we deal with the questions that leave a remainder. So let's say the number is n, there's any number n and it has to be divided by 5. So when we divide n by 5 and it is leaving a remainder, let's say r. It means that n is not completely divisible by 5 and the remainder it leaves is r, means this is something extra. So what we do is, if we remove this r, if we subtract this r from n, we get the number that we get will be exactly divisible by 5 and we will not get any remainder. So we have removed the remainder from that given number. Okay, let's understand this with the help of this example. Now in this case, the first case is where we are talking about the same remainder. Let's read the question. Find the smallest positive integer which when divided by 12, 15 and 20 leaves a remainder 4 in each case. So the number has to be divided by 12, 15 and 20. And the remainder is same, which is 4. Now since we have to find the smallest positive integer, so the first step is to find the LCM of those numbers. So to find the LCM, let's use the laddering method. So the numbers are 12, 15 and 20. So we find their LCM. We start with 2. Then we have 15, 2 5s are 10 here, then we divide by 3, 5 15, we have a 5 and then we divide by 5. So here we have all the numbers divided, so the LCM will be the product of 2 times 3 and 5. So 2 to the 4, 4 to 3 is 12, 12 5s are 60. So 60 is the LCM. Now what we learned was that we have to, from that number that we want, we have to subtract the remainder to get the least common multiple. Okay, so the least common multiple here we have got is 60. So let's just write LCM first here so that our formula gets completed. So the number that we are looking for would be the LCM plus the remainder which is given to us in the question. So LCM is 60, we add 4, we get a 64. Now you can also check this answer. 64 divided by 12, you get quotient 5 and the remainder is 4. If you divide 64 by 15, the quotient is 4 and the remainder is also 4. And if you divide 64 by 20, you get quotient as 3 and remainder is 4 again. So hence 64 is the number that we are looking for. Now this was when we have the common remainder. We have the same remainder across. Okay. Now this is a question, a second case scenario where we can have different remainders for each divisor. Let's read the question. Find the smallest positive integer that leaves a remainder of 8 when divided by 12, 11 when divided by 15 and 16 when divided by 20. So what we do in this case is that first of all, I've just mentioned it here, we find the difference between each divisor and its corresponding remainder. So each divisor, so it's 12 here and its corresponding remainder is 8. We find the difference. So the difference is 4. The next divisor we have is 15 and its corresponding remainder is 11. So we have 4 again as a difference. The third is 20 in the divisor and its corresponding remainder is 16. So we get a 4. So here we see that we have a common difference. Okay, so after finding out this difference, if it is common, let's find the LCM. Now LCM we have already got in our previous example, so I'll just write the LCM straight. Now what we do is the subtract the common difference. Now what was the common difference? Let's say this is D. I subtract the common difference from the LCM to get the number. So that would be 60 minus 4 is equal to 56. So now you can check by dividing 56 by all three numbers, and the remainder that you would get should be the same. It is just to check your answer, cross check. So just a quick recap. If it is same remainder, the required number is equal to the LCM plus the remainder. If you have the different remainders from each divisor, find the common difference. The required number will be equal to LCM minus the common difference. Now what if the difference is not common? It is different. It is not constant. So for that I'll make another video. For now you have this practice question for yourself. Do this question and write your answer in the comment box below. If you have any doubts, do let me know. We'll take it up in the next video. Till then, take care. See you in the next.